Fabry-Perot Etalon. Display 1 depicts a glass plate of refractive index n, thickness d, and inner surfaces reflectance r. A light beam, A, of wavelength lambda falls on the plate at an angle theta from below. The light makes multiple reflections on the plate's inner surfaces. On each reflection from the upper surface, a small fraction t of the light transmits to the outside. The transmitted waves emerge with a common angle theta with the normal line. However, the waves differ in phase angles due to the different optical path lengths of the wave inside and outside the plate. The red waves 1 and 2 are two typical consecutive transmitted wavelets from the upper side of the plate. The yellow wave in the middle is a pointwise algebraic sum of the two waves' displacements. Wavelength lambda is varied in the control panel, while the angle theta is kept unchanged. At some wavelengths, the transmitted waves interfere fully constructive together, giving rise to a transmitted wave of maximum intensity. At slightly different wavelengths, the algebraic sum of all transmitted wavelets' displacements becomes zero. The wavelets interfere destructively together, and thus no wave is transmitted at these wavelengths and the given view angle. The incidence angle theta is now varied in the control panel, while the wavelength lambda is kept unchanged. At some angles, the transmitted waves interfere fully constructive together, giving rise to a transmitted wave of maximum intensity. At slightly different transmission angles, the sum of all transmitted wavelets' displacements becomes zero. The wavelets interfere destructively together, and thus, no wave is transmitted at these observation angles and the given wavelength lambda. Display 2 depicts the angular resolution of atomic spectral lines by Fabry-Perot's Etalon. The reflectance of the Etalon's inner surfaces is varied in the control panel. We observe that the interference line's width diminishes with increasing reflectance. Our adjacent spectral lines become highly resolved from each other with R values approaching 1. Visit the website www.cyberphysics.academy for a full view of the tutorial. Send comments to contact@cyberphysics.academy.